You are now being connected to your conference. Hello.
Hi, how's it going?
Fine, how you doing?
Doing all right, just sort of struggling with a problem.
Okay.
So I did put it on the board. Hopefully that's apparent on your end.
Yes, it is.
So I don't have any problem with part A, but part B is where I'm personally struggling.
Okay. Sketch the graph of C prime of T. What does the graph tell you?
Yeah, usually with, sketching the graph of derivatives, like they've always given me a graph, and then, that is just the curve itself, like it has like these points where the gradient, like where the m value or the tangent line is 0. And so I'd often just replicate that and then use those points as a reference. But here, the gradient is never 0, so I'm having trouble crossing that bridge.
Okay. The derivative is slope, and maybe that's what I'd look at, are the values of the slope. Like close here, like between 0 and 2, about what is the slope?
It's positive, I can tell you that much.
Right. Maybe it's about 10, right?
I'm not too sure what you mean by 10, because my understanding was that the slope was always just the inclination of the line.
Yeah, I was kind of looking at this. Estimated that this was, I don't know. Maybe I was looking at what I thought would be 1. Looking at the, you remember your slope formula from line.
Right.
You've got the y1 minus y2. I was just kind of estimating. It is up high, and then as your time goes on, your slope kind of starts decreasing, right? Like this would not be quite as steep as it is closer to 0. And then your slope here really is starting to approach 0, right?
Correct.
So I think your slope would be maybe going something like this and getting closer to 0. Does that make any sense?
I was following you when you said, which made a lot of sense, when you said that, the slopes are always positive, but the positive slope is decreasing in a way.
Yeah.
I was with you there, and then when you made this jump here with this particular shape, I'm not too sure what to make of that.
Okay, I'm starting with I don't know, I called it 10, but you didn't quite like that. But I started with a high positive slope, which is, this is a high on the positive end. And then my slope is approaching 0. Maybe I shouldn't have touched your x-axis, but it is getting closer and closer to 0, right?
Oh, okay. So you're saying that this graph represents the fact that the positive slope, it's very positive at first, and then the positivity is decreasing. So you're saying that that could be represented as, a very high positive value, and then because you're saying that it's getting closer to 0, you're saying that, I guess, yeah, but aren't like
yours looks more accurate than mine does. I got too close to my x-axis, but yeah, you see how it's approaching 0.
Right. So the tangent lines, I'm just trying to wrap my head around this. So the tangent lines are approaching 0.
Right.
So it was really positive at first, so I chose a high value on the
Right. And that's why all of your slope is above your x-axis, is because the slope is always positive. It's just getting closer and closer to 0. As this flattens out on your original graph, as it starts to flatten out.
Well, the thing that I'm having trouble with understanding is that, like, if this were 1, 2, 3, and so forth, we're trying to say that, like, the tangent lines are getting less positive, but as we move in this direction, our x values are actually getting higher. So shouldn't that indicate a higher positivity?
Okay, but, okay, this is, you're looking at your slopes relative to time, right?
Right.
If I were sloping, sorry, if I were graphing this on the same axis, I'm going to change colors. Okay.
Mm-hmm.
See, here at 12, I'm really getting closer to 0 because this is so flattened out.
Right.
At 10, I'm a little bit higher. At 8, let's see, it's probably about 4. I'm at 1, and this is totally because my Y's percent full change are going from 20 to 100. It's not drawn to scale at all.
Right. So
Okay, I guess what I would like on your graph, I would correspond to the 12 rather than go 1, 2, 3. I'd go all the way up to 12 because that's when it's most close to 0. Because it takes about 12 hours to completely charge, right?
right. Right.
When it's completely charged, there is no more slope to your graph because I can't go above 100% of full charge.
So then why is it going to 0 then? That doesn't make a lot of sense, right?
Okay, but it's the slope that's going to 0. It's okay. You plug in your cell phone. Your cell phone needs to charge.
Mm-hmm.
When you first plug it in, if it's close, if it's hardly charged at all, you plug it in, it starts to get a big charge right away.
Right.
It starts climbing faster, and then as it gets to closer to full charge, it doesn't go so fast. That's exactly what this original graph does.
Mm-hmm.
Okay,
Mm-hmm.
it's like in 4 hours, I've got nearly 80% charge after 4 hours, but it takes 12 hours for the full charge.
Right.
Okay.
Yeah.
So this is why you have to think of these Y values as rate.
Mm-hmm.
This is not the same graph. Okay.
Right.
At immediately after 0, I have a pretty high rate of gaining power, of gaining charge in my cell phone.
Right.
Okay.
Yes.
That's my Y value is high, but as I get closer to 10 and 12 hours, my rate of change for the full charge is not going near as fast. It's getting closer to a flat line, a 0. That's why the decline in my function.
I see. I see. So
Does that make sense?
yeah, definitely. I think what you said about the fact that this graph in particular was a rate makes a lot of sense.
Yes. Right. So
So
my X is still my time. This is still time.
mm-hmm.
But my Y is going to be actually the rate.
Right. The rate of the change in percentage.
Right. That's when you say sketch the graph of C prime, what does the graph tell you? It tells you initially I have a high rate of charge, and as time goes on, that rate declines nearly to 0.
I see. So hypothetically, I'm on whiteboard too, by the way. Hypothetically, if I had something like this, for instance, could I sketch the derivative of that? Is that possible?
Yeah. Now, generally, what are your slope doing? What's the slope doing for that function?
Well, so as we're moving rightwards, first first I'd say it's negative, and then it's getting closer to, I want to say 0.
Right, because this is getting flatter.
Right, it's getting flatter. So if it's negative, then I'd really have to start in the negative regions of the coordinate plane. So I would say that, it's really negative at first. So I'd maybe start somewhere down here. And then it's gradually getting less negative. So
right.
Maybe I take, and then it's getting to 0. So maybe I'd say something like this.
Perfect. That's exactly right.
I see. Yeah, I think what you said makes a lot of sense. When you think about it as not the percentage itself, but the rate of the change in percentage, That's really what bridged
Right.
the gap. Yeah.
Right. And so that's the second part of your question, right?
Yes, yes, that is, and for sure. I think actually, you know what? I think because I tried answering the first part, but I think the first part alludes to what the second part would be.
Right. And I think it's important to think about what that second part is so you understand how to grasp the first part. I think you're right.
Yeah, certainly. Oh, you're talking about what does the graph tell you?
I'm going back to that first page
Mhm.
for the board number 1. You see what does the graph tell you?
Right.
The graph, and if you were to think of the change in your slopes, which is like what we were thinking of, they are pretty highly positive at first, getting closer to 0. So the graph actually tells you that my rate of charge decreases as time goes on, right?
Right. Right.
And that's exactly what your graph is showing you. Anyways, I just thought that you were saying, thinking about that, what does the graph tell you, will help you sketch the graph.
No, what I was saying before I actually thought you were referring to what does the graph tell you, but what I was referring to was part A. And I think fully understanding part A and what it means to look at the
Oh, I
derivative.
gotcha.
Yeah,
Okay, yeah,
I think that would have helped me, like part A in a way tells me that the derivative of the graph is in fact the rate of change. So if I would have, I think, elaborated more on part A,
oh,
then
sure, that would have helped you.
yes, absolutely.
Yeah, I understand now. Sorry,
Yeah,
but I
no
did not
problem.
understand before.
No problem at all. So yeah, I think this concludes it, and I'll make a note of this and maybe try a couple more on my own, like I did on whiteboard 2, and see if I can sort of make up my own scenarios and so on and
Sure.
so forth. All right, well,
Okay.
have a wonderful night. I really appreciate it once again. I remember back, I think at least 6 months ago, you were helping me out with basic math, and here we are.
Oh, sorry. Okay, well, that's great. I
Yeah.
don't remember, sorry.
Yeah, that's fine.
Okay, well, have a
I
good night, you
You
too.
too. You too. Bye.
Bye-bye.